Question number 35. Each of the registers shown in the figure has a resistance of 10 ohm, and each of the batteries has an EMF of 10 volt. Find the currents through the resistors A and B in the two circuits. This is 10 volt battery. This is also 10 volt battery. This resistance is 10 ohm. This resistance is 10 ohm. We have to find out the currents through each resistor. So here, if we consider this loop, so direction of current will be like this. Suppose current is I1. So I1 is equal to 10 divided by 10. So that will be equal to 1 ampere. Now, if we consider this outer loop, so suppose current is I2. So we can say I2 times 10 equal to value of battery. This is 10 minus 10. That is 0. So I2 will be 0 ampere. Now consider this circuit. In this loop, suppose current is I1. So 10 equal to 10 times I1. So that gives I1 equal to 1 ampere. The same is true here. Suppose this current is I2. So if we consider this loop, this is 10 ohm. So I2 will be again 10 by 10, that is 1 ampere. Now, if we consider this outer loop, so total voltage, suppose current is I3. So total voltage in this outer loop will be equal to 0. So I3 will be equal to 0. Now, let's take question number 36. We have to find out VA minus VB. This battery is E1, this battery is E2, and the same figure is shown other way around. So both figures are equivalent. E1 along with the resistance R1, E2 along with the resistance R2, and this is R3 resistance. We have to find out VA minus VB in the two cases. So let's consider this case. Suppose we assume that E1 is greater than E2. So E1 is sending current I, and suppose I1 current enters this branch, then the remaining current I minus I1 will enter through this resistor. Now, if we consider this loop, loop number 1, so it will become E1 equal to I times R1 plus I1 times R3. Suppose this is equation number 1. Now, if we consider this loop and we go like this, so E2 is equal to I1 times R3 minus I minus I1 times R2. If we open the bracket, it will become this minus minus will become plus. So we can say I1 times R2 plus R3 minus I times R. Equation number 2. We have to eliminate I from both equations. For this purpose, if we multiply this equation by R2 here and this equation by R1, so what do we get? We will get E1 R2 equal to I times R1 R2 plus I1 times R2 R3. And this equation will become E2 times R1 equal to I1 times R2 R1 plus R3 R1 minus I times R1 R2. If we add these two equations, so this term will cancel out and we will get E1 R2 plus E2 R1 equal to I1 times R1 R2 plus R1 R3 plus from here R2 R3. Now we have to find out I1 plus. So I1 equal to E1 R2 plus E2 R1 divided by R1 R2 plus R2 R3 plus R3 R1. Here, our concern is to get potential between A and B. So it will be equal to I1 times R3. I1 is this. So let's write it as VAB equal to I1 times R3, which is equal to I1 equal to E1 R2 plus E2 R1 times R3 divided by R1 R2 plus R2 R3 plus R3 R1. Now we can do one thing. We can open the bracket of the numerator and then divide each term by R1 R2 R3. So dividing each term by R1 R2 R3. So VAB will be equal to here E1 times R2 R3. So we will be left with E1 upon R1. Here it is E2 times R1 R3. So we will be left with E2 upon R2 divided by. When this term will be divided by R1 R2 R3, we will get 1 upon R3. From here we will get 1 upon R1 and from here we will get 1 upon R2. So which is our answer. Thank you for watching.